Hey guys, have you been recently concerning the operation of the LED sports application? Aside from the graded slate, we can also do some other intriguing stuff. In the Sufficient IoT join directory, a few other procedures are available, such as the scrolling I love you effect. Secondly, there is another application associated with the sensors. Okay, we will utilize a light intensity sensor. BH1750 is the light intensity. The pinpoint is listed below. It's right around the color. Just right here, let's connect the necessary wires. Because the I2C bus is already presented, it's already linked to the Groove interface, but I don't have a Groove interface cable, so I connect it immediately using this cable. The reset pin can be directly supplied with 3.3 volts. Well, the light intensity sensor is already connected, as you can see. Let's get started. Let's try it. The RGB light intensity can be fixed by the light intensity. This is a demonstration of functionality of enhanced version. The IoT feature is the core of the Sufficient IoT Hub. Let us now demonstrate the IoT function. The circuit has the default configuration. A SX1260 and the RF circuit has been included into the circuit. The IPX antenna connector is shown below. An antenna must also be connected for the LoRa function. It includes a ready-to-use Sufficient IoT application. It can be found in this directory. We can get straight to it. Let's begin by generating the makefile file once under normal conditions. Because I already generated the makefile, we get this result. Now you may build the code. This associated file is pretty large, thus compiling will take some time. Then, throughout the compilation process, you may come across SD card and TF card. There is insufficient space on the TF card. One example is how to increase its default disk space. Increase the size of SD card as much as possible. For example, if you have an 8 GB SD card, here's how you enhance its capacity and how to create a swamp memory. Okay, it's done. Following the compilation, you may need to activate it the first time you run it. Because each Sufficient IoT Hub ID corresponds to a separate license. The license for each Sufficient IoT Hub can be found at the URL below. This is the license for the Sufficient IoT Hub's ID. This is the location to config. In the build folder, in the build directory, check this box. The preceding content is removed here. Insert the material into it. Commas should be used in space of spaces. Save it with a capital S. Press Q to exit. Let's check whether the license is activated or not. Okay, here you go. It's already running LoRaWAN code. The following step is configure LoRaWAN. Let's put an end to it. The configuration parameters remain in the menu configuration under the build path. Each parameter's specifics is on the page of the documents. Set high frequency to US 915. Then perform bit synchronization in class A8. LTAA network method. If we use LTAA network approach, we must make changes. The setup of its associated parameters is shown below. Following the modification, let's troubleshoot the level. That is how the frequency and the interrupt information are printed. This should be kept as the default. We can send 16 hex data for today's test. Then we transmit 0, 0, 0, 1, 0, 2, 0, 3 along with 4 bytes of data. Here are some more default sensors. Here the duty cycle is 15 milliseconds and we only send it once. ADR and AC key are two other settings. Okay, here's the standard setup. We're now carrying out LoRaWAN communication. We must use a gateway. This gateway is well built and has a great looking. As an indoor LoRa gateway of high-tech, there is a wall holder here. We may secure it to the wall using this holder. The following items are used as accessories. One is antenna and an extension. We do not use an extender for today's test purpose. We can simply connect them. The LoRa antenna is shown here. This gateway includes a Wi-Fi antenna as well as the power supply. Now let's switch on the gateway. Turning on the gateway for the first time may take around 1 minute because it also serves as Linux boot. For the gateway's operation, LoRa Gateway 7603 has a full instruction for using this gateway. After you run it, it will construct a wireless access point with this name. You can use this IP address to log in. This is the default password. It has all of the corresponding configurations for LoRa, Wi-Fi status, and so on. The RGB light is now turned on. It indicates that the gateway has completed its startup. Then we can connect its IP address here. Well, now that we've connected, we can input this IP address to see the setting page. healthtech.org is the default password. As you can see, we have all the gateway status here. The server can be found here. When we do the LoRa communication, a LoRa gateway is needed. Let's use the HealthTech test server for this. This is the LoRa gateway's ID. That is equivalency to the gateway's MAC address. Let's say set the US 915 for testing purpose. You can configure the Wi-Fi that the gateway needs to connect it to in the Wi-Fi option, or you can use the network port to interact directly. We've already configured this gateway, that's I won't try to demonstrate it here. Now we will restart the network now. Okay, we will also launch HealthTech's test server. Log in from this page. You can use your HealthTech website account to log in. First thing first, create a gateway. This time we require the gateway ID. Please copy it here. This is the UI gateway. This will be determined by the EUI. A user created ID, change the name. We're establishing the US 950 here. The frequency range is 0 to 7. The US FSP1 is chosen here for restriction gateway. The packet has not yet arrived. We will have to wait approximately 1 minute. Package arrived, it will appear as connected. Because we've changed the networks, so let's get back together here. Okay, fine. When it comes to the communication, the 7603 is acting as a gateway. Sufficient IoT Hub functions as a node. Let's make a load. First, develop an application. Create a LoRaWAN 102 version B device Procto version within the application. That's all there is to it. The joined UI can be customized here. Join the UI in this OTA. The join UI can be customized here. Join the UI in this OTA. It's an app's user UI. It's just zeros around here. We can configure everything. Alternatively, we can modify it based on your own requirements. Okay, now we set the device UI to 89 here. Instance net, let's make it 90. Well, copy it by right-clicking on it. Now we come to the app key. All of them are 8. Well, okay, no problem. Exit. I'll execute it. It's already transmitting. Someone has accepted its request as seen here. You can see this is also synchronized, join and joined. It will get an RX acknowledgement signal after a successful launch. The data we are sending is payload 11222366. The base 64 format. I didn't configure the decoding script in this location. We can make certain that the actual data being transmitted is 11222366. Let's put an end to it. Data we transmitted is a cast metadata for today's test purpose. This is set to 11223366. It corresponds to this one. This must be in hexadecimal. There are also some demo sensors integrated by default. For example, HTC 1080 and BMP and demo sensor data. If you're interested, you can play with it. For reading out the sensor data, and then through the LoRaWAN protocol transmit it to the gateway. Upload the data to the cloud platform. Okay. If you're not unsure about using it from the command line, this adequate IoT Hub also includes a web configuration mode. Let's give it a shot. Okay, it's up and running now. This is its internet protocol address. Let's copy the IP address here. It's right here. It supports all of the Sufficient IoT Hub's applications. This includes GPIO and PWM control. Options for I2C scanning and LoRa control. Far more convenient. Let us compare and contrast. Functions are interchangeable. Okay, let's conclude this segment. This time we transmit simple hex data as our customer data. In the following video, we will show you how to obtain sensor data and send it to LoRaWAN protocol, while LoRaWAN protocol to the gateway in order to perform some simple applications. Thanks for watching. See you next time.